we refer to multi-step inequalities, we're looking at inequalities that are not simplified. We need to combine like terms and distribute before we can solve and then graph. This is no different than when we distributed in equations. We start by distributing. The distributive property is just applied multiplication. It's when I have a 2, 3, however many term algebraic expression in a set of parentheses and a value that's right outside being multiplied by each term. It's like trick-or-treating. If I don't multiply 3 by 2x to get 6x, or 3 times 9 to get 27, I'm going to get my house egged. 6 is just by itself. Now I can check if I need to combine like terms. 6x plus 27 is already simplified. 6 is already simplified. Sometimes the hardest part of combining like terms is proving to yourself that terms have already been combined. There's nothing left to simplify, so I can decide what type of equation you have after simplifying the equation. Is this a one-step or two-step? I see two steps. I see two operations. I'm multiplying by 6 and adding 27. So to solve, I need to go use my inverse operations in an inverse order. I'm going to subtract 27 from both sides. That's going to give me 6x equals negative 21. And then I'm going to divide both sides by 6. That's going to give me x equals negative 3.5. On your own, try to solve and then graph this inequality. Keep in mind what we just reviewed about distributing in an equation. When I have a multi-step inequality that includes distribution, first thing I do is distribute. I see 4 times x plus 2, so I distribute to both of the terms. 4 times x is 4x. 4 times 2 is 8. If you need to draw in the little arrows, it may help you. Everything else comes straight down. Minus x is greater than or equal to 20. Everything needs to come down. Be careful. Don't make a mistake because you forgot a negative or forgot a value. Now I'm going to combine like terms on both sides of the inequality. I see 4x plus 8 minus x. 4x minus x, those go together, and 8 is its own term. It's a constant. That's going to give me 4x minus x, which is 3x, plus 8 is greater than or equal to 20 because nothing combines on the right. The right side's already simplified. Once I've simplified it down, I can decide what type of inequality you have after you simplify the inequality. It needs to be simplified first. Here I have a one-step or two-step. Well, I see two operations. I see times 3 plus 8. So I need to go through and solve this. My operations, according to the order of operations, are times 3 plus 8. So to do the inverse operations in the inverse order, I'm going to subtract 8 and divide by 3. Subtract 8 from both sides, it's going to give me my identity on the left, so I'm left with just 3x plus 0, which is just 3x. 20 minus 8 is 12. Then I said I'm going to divide both sides by 3. So x is greater than or equal to 4. The inequality symbol stayed the same the entire time. The only time it changes is when you multiply or divide by a negative. Now I need to graph my answer. I start by plotting my point. In this case, it's a closed point. 4 is included as one of the solutions. So it's going to be closed at positive 4 on the number line, determining which direction the arrow is shooting. Do not use shortcuts. The best way to do this is to simply plug in a point. It'll help you build understanding of inequalities that'll help translate when you get into two-dimensional inequalities or linear inequalities. So I'm going to pick a point. I love 0. 0's great. All positives are greater than 0. All negatives are less than 0. I have a great basis of comparison with 0. Is 0 greater than or equal to 4? Is it possible that nothing is bigger than any possible or positive number? That's not a true statement. That's false. So I'm not going to point to the left where 0 is. If you're not convinced, check any point on the left side. Negative 5 is not greater than 4. 3 is not greater than 4. However, the points to the right, 5 is greater than 4. 6 would be greater than 4. 20 would be greater than 4. 8 billion would be greater than 4. This skill becomes a challenge if you are not using one of these methods. Let's try a couple problems together. I'm going to start by distributing. Negative 2 times x is negative 2x. Negative 2 times 5 is negative 10. And then I bring everything else down. Plus 5x, 8 is less than. I can combine like terms. There's nothing to combine on the left. It's already simplified on the left. But I can combine like terms on the right. Negative 2x and 5x. Negative 10 is a constant. So negative 2 plus 5, I add my coefficients, I get 3x. Minus 10 is just minus 10. There's nothing to combine there. Anything that did not combine drops straight down. Now I have to decide, is this a one-step or two-step inequality? I see two operations. I'm multiplying by 3, and then I'm subtracting 10. So I need to do the inverse of that. That's a two-step equation, or two-step inequality. I'm multiplying by 3, subtracting 10, so I need to add 10, divide by 3. So I'm going to write my work up here, give myself a little more room. I'm going to add 10 to both sides. On the right, negative 10 plus 10 gives me my identity of 0. Check it every time. You don't want to assume it just cancels out. 8 plus 10 gives me 18 on the left side. 18 is less than 3x. Notice that the inequality symbol does not change. The next step that I'm going to take is I'm going to divide both sides by 3. I know that because the first operation in the original inequality was times 3, so the last inequality, or last operation in this inequality needs to be dividing by 3. 18 divided by 3 is 6. 3x divided by 3 is x. Notice that the inequality did not change. This is an example where graphing with a shortcut would be a challenge. I would have to time now to flip around my inequality, make sure that the x ends up on the left, the 6 ends up on the right, make sure the less than symbol turns into a greater than symbol. It's a lot of extra steps just to effectively do a shortcut. The best way to do this, pick a point. So after I plot it, it's an open point at 6. I need to find all the values for x that are greater than 6. 6 is less than x, so x is greater than 6. Best way to do this, pick a point. 0's dead center. All positives are greater, all negatives are less than. So if 6 is less than 0, that's a false statement. 6 could not be less than 0. Positive values could not be less than 0. So I don't point at 0, I point away from 0 on my number line. If I get a false statement, I point away. If I get a true statement, I point at. I could also check these points now that I have it. 6 is less than 10. 6 is less than 15. Those other points prove that my solution's correct. That's where all of my solutions are located. All of the values that make this inequality true are located in that direction. Next problem, I'm going to distribute. 5 times negative 2.4 gives me negative 12. 5 times x gives me 5x is less than or equal to negative 25 plus x. I can't determine whether it's a one-step or two-step equation, and I can't start solving until I've combined like terms and simplified all the way. So simplifying, I've already distributed, now I just need to combine those like terms. On the left side, there are no like terms. Negative 12 and 5x are unlike terms. It's like oil and water, they don't mix. On the right side, negative 25 and x, also unlike terms. However, I see variables on both sides. This is when we need to combine those x's on one side of my inequality. So I'm going to move over my negative 5 or my 5x by subtracting it. If I subtract 5x from both sides, 5x minus 5x is 0, so I'm left with negative 12 on the left. 1x minus 5x gives me negative 4x. Now I can determine, is this a one-step or two-step? I see two operations, so it's a two-step inequality. I need to solve it using my two-step methods. If you're doing this in your head effectively and correctly, great. If not, take the time to write out your operations as they happen and the operations that you need to undo. So the first thing happening, I'm multiplying by negative 4. Multiplication comes before addition subtraction. Then I'm subtracting 25. Be careful, that's negative 25 minus 4x. I could rewrite that to negative 4x minus 25. Subtraction and negatives present similar concepts. Something is being taken away or missing in both cases. So if those are my operations in their correct order, I need to take their inverse order using inverse operations. Instead of subtracting 25 to solve, I'm going to add 25. That will undo the inverse operation of subtraction. Times -4, I need to multiply by -4. Notice the operation and the value are very important to note. The operation changes, but the value does not. -4, -4. So I'm going to add 25 to both sides. I'm going to give myself a little room, move my work up top. 25 to both sides, -25 plus +25 gives me my identity of 0, leaving me with -4x on the left. -12 plus 25 gives me +3. Now I need to take the time to divide by -4. That'll get my x by itself, and then 13 divided by -4 is -3.25. -4 divided by -4 is my identity of 1, which means it did in fact cancel out. Always prove it to yourself that that variable is left by itself, that the values are canceling. Something interesting happened when I divided by a negative. I ended up having to flip that inequality around. We were less than or equal to, now we're greater than or equal to. So I start by plotting my point. It's going to be closed because of the equal to aspect of the inequality symbol at -3.25. Whenever I have a decimal or a fraction inequality, I need to brainstorm and estimate where it's located. It's going to be between -4 and -3. It's a quarter of the way past -3, so it's going to be a little bit closer to -3 than -4. It doesn't have to be perfect, but practice those estimation skills as you plot. I'm going to pick a value. 0 is always great. Positives are greater than it. Negatives are less than it. So when I plug this in, could a negative be greater than or equal to 0? That'd be impossible. No value, no negative value, could be greater than 0. So I'm not going to point at 0. I'm going to point away from it. If you wanted to, you could check some of those points. -3.25 is greater than -5. It is greater than -10. It is greater than -15. Those are all true statements. Where the arrow's pointing, it's pointing at all of the true statements that make this inequality equal. On your own, go ahead and try these last two problems. Take the time to distribute, combine like terms. See if you need to combine like terms across the inequality using your inverse operations. Once you've simplified it, take the time, ask yourself, is this a one-step, two-step, how many steps? That'll help you determine how you're going to solve the inequality. Once you have the inequality solved, you're going to plot it. You start by finding the value in your final solved solution, plotting a point, either open or closed. Closed if it's equal to, open if it's just less than or greater than. The direction of the arrow is based on true or false statements. Substitute in a point. If you get a true statement, point the arrow at the value that you substituted in. I like 0. 0 has a great basis of comparison. If you get a true statement, point at it. If you get a false statement, point away from it. Shortcuts can be used, but they only work in certain situations. Some shortcuts require you to do so many steps before the actual shortcut that you may make mistakes and not get to your correct answer.